All right, so the dilation is a transformation that changes the size of a figure but not its shape. And we just talked about similar figures from last year. Similar figures, we knew that they meant they were alike. They had corresponding sides that were proportional and corresponding angles that were equal or congruent. Remember last year when we had similar figures? Those are dilations. So if a dilation changes the size but not the shape, go ahead. Does that mean I can start with a triangle and dilate it and end up with a square? No, I could only either get a bigger triangle or a smaller triangle. All right, I need you to write down that first sentence. That is our vocabulary word scale factor. So skip a line, write this sentence. The scale factor is a ratio of change between the two sides or the change between two ordered pairs. If you remember from yesterday, remember when we had those ordered pairs and we multiplied them by that scale factor? So that's what we mean by we change those ordered pairs. Today you're going to see how we can change the sides, okay? This next sentence you don't have to write. It's just a reminder. It's just a reminder that scale factor is the number that we use to multiply to find that change. The number you multiply by to get this change from the first shape to the second shape. You don't have to write that sentence. What you can do is you can kind of come out to the side, draw an arrow to the margin, and maybe make yourself this note. Multiply only. That's super important. Multiplication is the only operation we can use with scale factor. We cannot divide to find scale factor. We cannot add or subtract. We're using multiplication. Okay? So just that top sentence, and we're just adding in that we're multiplying only. All right, I don't need you to write the sentence. I just need you to draw the two triangles. Draw the two triangles. Make sure you label them with the R's on the inside, and then you put their side measurement, the 2 and the 4. We'll get it at the end. Okay. So just draw your two triangles. Draw your two triangles, label them with the R's, and then write your side measurements. Before we start talking about the scale factor, do you remember this little symbol right here? Right there? That little apostrophe? What does that apostrophe mean? Prime. It's called a prime. It's a prime symbol. And if a label has the prime symbol on it, what does that tell you? It could be a reduction. It's whatever the new image is, whether it's a reduction or an enlargement. It could be either one. You're right. So the prime symbol just tells you that that is the new image. All right. So this sentence, it says, if a shape becomes twice as big, keyword twice, the scale factor would be what? It is an enlargement, but if I'm starting at 2 and I'm getting twice as big, if I'm getting twice as big to 4, and I can only use what operation? Multiply. So 2 times what gets me 4? Times 2. So my scale factor would be 2, right? That was what we did yesterday. Remember we took that shape? We multiplied all our coordinates by 2, and we got a shape that was double in size. All right, draw these examples, these two circles. Make sure you label them. We don't need computers right now. All right, in these images, I'm also giving you the distance across the circle. Anybody remember that distance across the circle, what that means? Yes. It's the diameter, the big word, diameter. If you were in my class last year, you better not forget we read a bunch of books about it. Right? I feel like that's a personal attack on my theatrical style of reading the books. So we know that this distance across the circle is the diameter. We're starting with the pre-image and we're going to the new image. If the shape shrinks to half its size, what do you think that scale factor is going to be? It is a reduction, but what is the scale factor? What's half? Think back what we did yesterday. Yesterday we multiplied by 0.5. So I could write that as a decimal, or I could write that as a fraction. How would I write it as a fraction? 1/2. Very good. Very good. All right, you don't have to write this, but I'm just going to ask you some general questions. If my scale factor was triple in size, what would that be? What would I be multiplying by? Times 3. If it was triple, it would be times 3. I was trying to stump you. Triple times 3. All right. I only need you to write down this first sentence. First sentence. When going from a small shape to a larger shape, the scale factor is greater than 1. I would put a star out next to it. This is important to know. Greater than 1 is underlined. Do you think that's important? Yes. So when you're going from a small shape to a larger shape, the scale factor is greater than 1. You're writing the sentence. You don't have to draw the picture. This is the one we just drew. We said our scale factor was 2. Is 2 larger than 1? Yes. Yes, so that would make an enlargement. It's getting bigger. Small shape to a big shape, my scale factor has to get bigger as well, greater than 1. All right, this next sentence you're going to be writing down as well. And it's important. When going from a large shape to a small shape, the scale factor is less than 1. So up here we had greater than 1, made an enlargement. Here, if my scale factor is less than 1, it makes a reduction. Remember that when we multiplied by 0.5 or 1/2, my shape got smaller. In that example that we just talked about, my scale factor was 1/2, so it resulted in a smaller image. Again, you don't have to draw the picture, you already drew it. So let's talk about scale factor. What if I told you my scale factors, I'm going to give you a couple of different scale factors. What if I told you my scale factor was 3/4? Is that going to be a reduction or an enlargement? That'll be a reduction. How do you know? It's less than 1, you're right. What about if I told you my scale factor was 90%? What is 90% as a decimal? 0.9 or 0.90. So that's less than 1. It is a reduction. Anything over 100% would be an enlargement. What about if I said my scale factor was 9/4? But it's a fraction. Isn't a fraction always a reduction?
No, some fractions are more than 1.
Yeah, this fraction, is that greater or less than 1? Greater than 1. So you're right. That is an enlargement. All right, now I'm going to stump you. You ready? What if the scale factor was 1? Exactly 1.
Reduction. No.
What did you say? It would be equal. Think about the picture we did yesterday. If I multiplied all my coordinates by 1, what's going to happen? They're going to stay the same. So a scale factor of 1, it doesn't reduce or enlarge. It just stays the same. Okay? What about if my scale factor was 0? Think about the ordered pairs. What happens to them? Something happens. If I multiplied all my ordered pairs by my scale factor of 0, what happens to the new ordered pairs? They're all 0. So that's just a point on the origin. So we cannot have a scale factor. It makes it go away, right? Every point would be at the origin. So you're never going to have a scale factor that's 0. In the same regard, you won't have a scale factor that is going to be a negative number. Okay? All right. So we already talked about exactly 1. You ready for your quiz?
Yes.
No.
All right. What about we do it together?
No.
Yeah.
Okay. Don't shout out the answers. I want you to think about it, and then I'll ask for the answers, okay?
Okay, I'll just wait.
Think about it. Scale factor is a number that we blank by to get the new image. Think about it. Don't shout it. What are we doing to that scale factor to get the new image? Everybody.
Multiply.
Good. Multiply. Scale factor is that number that we multiply. Is it a number that we can divide?
No.
No. The pre-image is our original image. The result of the dilation is called the, everybody, the new image. Or we can use that symbol called what?
Prime.
Prime. The symbol called prime. Good job. All right. This one, think about it. Think, don't answer. If our scale factor is greater than 1, what happens to the new image? Greater than 1. All right, everybody. Enlargement. Well, what does an enlargement mean? What if I don't know that word? What does that mean? It gets bigger, yes. I like that. Enlargement has the word large in it. Good thing. All right, what if our scale factor is less than 1? What happens, everybody? It reduces. What does reduce mean? Gets smaller. Not subtract. It just means it gets smaller. Because we're multiplying by a fraction. We're not subtracting. Remember, scale factor can only use multiplication. Okay? All right. Next one. I need you to draw these 2 triangles and label them in your notes. This is our first example. The red triangle is dilated. No, we're taking notes. So we're writing down the red triangle, the blue triangle, and we're labeling them. Which one's the new image? How do you know? It doesn't say new. It says the prime. So what I would do in your paper, I would go ahead and label this as new. And then you could label the little triangle as your old triangle. It does say pre, so that would help you clue you in too. Pre-image, it means it's what you started with. All right, so if we're starting from from little to big, what do we know has to happen with our scale factor? I'm multiplying, but what about it? I'm starting small and I'm getting bigger. Is it going to be less than 1 or bigger than 1? Bigger than 1 because I'm getting a bigger image. All right, what I want you to do is I want you to look and I want you to label the base length and the height length for each of these. Base, label the base length and the height length. You have to count your blocks. Tell me, how long is the base? How long is the height? Write it down, label them. All right, so you should have gotten these measurements, right? Remember, this is the old, this was our new. All right, so we know we're starting small, going to big, and we said our scale factor has to be what? It has to end up being greater than 1, right? Okay, so we have to think about it. We have to think, 5 times some number will give me 10. Now this one was really easy to think about it, but the numbers aren't always going to be easy. What if I started with a measurement of like 1.2 and I ended with a measurement of like 16.74? That's not easy math, is it? No. So we have to come up with a mathematical process. The first way we can do that is we can write an equation. 5 times some number equals 10.
2.
So our equation, 5 times some number, remember we put in a variable if we don't know it. So that says 5 times some number equals 10. Write down your equation. This is one of the methods we can use to solve scale factor. We know what the answer should be, but now we're going to prove it. Okay? So if that some number that I don't know is my scale factor, how do I solve for k? What do I need to do? Divide by what? I need to get k by itself, so what do I need to divide by? 5. What you do to one side? So k is equal to, what is 10 divided by 5? 2. Does that equal 5 times 2? Did that give me 10? Yes, so that's our mathematical process. All right? All right, next example. Write this in your notes. Next example. Write this in your notes. Which one is the old and which one is the new? The small one's the new. The blue one is the old. So are we getting bigger or are we getting smaller? Smaller. So what do we know about our scale factor? It better be less than 1, right? All right. So I want you to pick one of these measurements. Maybe 9. We're going to 3. So write your equation. I need you to draw your arrow and write your equation. 9 times some number equals 3. Think back to how we wrote the equation in the last one. So 9 times some number equals 3. No times. Oh, okay. So what are we going to end up dividing by?
9.
I'm going to end up dividing by 9. So, what is my scale factor? It is not 3. What is 9 divided by 3? Punch it in your calculator. It is not 0.3.
How would it be negative?
There's no negative scale factors. What do you get when you plug in 9 divided by 3, enter? No, you don't. Yes, I'm sorry, you're plugging in 3 divided by 9. I said it backwards. No, you don't get 0.3. You get 1 over 3. 0.3 repeating, but you said 0.3. Now, in scale factor, if you get a repeating decimal, they're going to use the fraction. Okay? Just so you know. Because I can't multiply by 0.3 repeating. Is there a way to put the repeating symbol in the calculator? No. So in order to get the answer, you would have to use your fraction. So my scale factor is 1/3. But when you look at these pictures, do you see how easy it is for your brain to say that it is 3? All right, go get another one. Just get the one over there by the table.
This is coming out of my face since I was talking.
Now, what we just did, we used 9 and 3. If we were to use 6 and 2 instead, should we still get the same answer? We should, because they're similar figures, right? So if we use 6 times some number that equals 2, divide by 6, and I still get my scale factor 1/3. So then 6 times 1/3 will give me 2. Okay? All right, so what we just did, you don't have to write this down. What we just did is we used an equation to find the scale factor. We took our pre-image times our scale factor that we didn't know, so we had to use a variable, and that would give us our new image amount. But some people struggle with writing that equation, so I'm going to give you another method. Okay? We could also use this method. Scale factor equals new measurement over old measurement. I want you to write this method down in your notes. Bubble it, star it, do something. Make sure you know, especially for those of you that struggled writing that equation, this will be the method that you use. This will be your formula. Scale factor equals new measurement divided by old measurement. That works. Scale factor equals new divided by old. Because didn't y'all just tell me that once we had to move it to get k by itself, we ended up using division as our process? That's the same thing that we're doing here. All right, write these examples down in your notes. These two rectangles. We do. When we're done with our notes. These two rectangles, which one is the old and which one is the new? Is it always the first and the second? Not always. But look right here. We're creating figure 2. So that means figure 2 must be the new.
It says, what has been new now?
And this is the old. So if we're starting with the old, going to the new, are we getting bigger or smaller? Bigger. So what should our scale factor be? Greater than 1. All right, let's do that new method. New over old. Somebody give me a new measurement. A new measurement, I heard 8 first. What is its corresponding old measurement? All right, so 8 over 5 could be a scale factor, or what is 8 divided by 5 and make it a decimal? You have a calculator, please use it. You should get 1.6. So, my scale factor is 1.6, or you might see it written as the fraction 8 over 5. We still could have used the equation. 5 times some number equals 8. Divide by 5. Look, right there is the same thing we did right there, new over old. So you can use whichever method you prefer. All right, you don't have to write this down, but let's look at it. What is the scale factor when figure A is being dilated to make figure B? Which one is the old one? But B is listed first. Because B is listed first, does that always mean it's the small one? No. We are making figure B, so that means figure B is new, and this is old. So if we're going here, we're getting smaller. Hold on. What do we know about the scale factor? The scale factor, look, we're going smaller. It's a reduction. So it's going to be less than 1. So can I eliminate answer choices? You can eliminate your whole number answers. So, new over old, 5 over 15. That gives me 1/3. All right?